Well, it's 72 degrees inside, about 32 outside, which means that my furnace is working. So, as you all probably, as you've seen my videos, I live in a rather cozy little ski shack, well, condo, but it's a pretty compact little cozy home. It's a 670 square foot condominium, townhouse style, so I have units on either side of me. And the benefit of that is I've been able to keep my heating costs at a minimal. I think my last heating bill was $19, and $5 of that was a meter reading fee. Now I heat with a liquid propane gas. The tank is actually, there's 2 tanks buried in the ground that serve the entire complex. They're way over there. Now all of these units were built in 1986. And they were designed to be low cost for the area, for heating and energy usage. In the 1980s, they were really getting into this whole energy conservation thing. So the walls are 11 million inches thick. They're insulated with both styrofoam and fiberglass. The ceiling is insulated with, I believe, styrofoam panels. And the doors and windows are all thermopane, really rated for efficiency. In fact, when they designed it, they used passive solar, which is why there's an 8-foot sliding glass door here, as a way to kind of lower the cost of heating with propane. And they used as little amount of windows as possible. There's only 3 windows in the entire unit. One in the bathroom. Of course, the door is a window as well. There's a window upstairs, and there's a window directly above me on the 2nd floor. It's an awning window, Anderson windows. That's what they used. But because of all those thermal considerations and efficiency considerations, they were able to get by with installing a single direct vent wall-mounted furnace in each unit. And these are designed with about 80% efficiency, 40,000 in, 32,000 heating capacity out. They're very low-cost operating units, and they're all exactly the same. They used the Williams Forsaire to solve that problem. They were a very inexpensive furnace today, and they were absolutely then. This furnace is so well made that they still manufacture the exact same unit to this very day. It costs about $1,000. You can order them online through Home Depot. And I still have the original unit. But what's happened is my furnace is starting to show its age. And what happened to most of these about maybe 5 to 10 years ago is that the fan motors started seizing up. That's the first clue. The second thing that goes wrong with these is the pilots have begun failing. And I'll get into that in detail in a bit. But what my neighbors are all doing is they're replacing the entire units with a very expensive Rinnai direct vent gas furnace with only marginally more efficient ratings. I mean, we're talking low numbers here. 3 to 5% rating improvement. Now let's backtrack a little bit. This is a standing pilot furnace, which means that the pilot runs 24/7. When it calls for heat, it kicks on the main gas valve, and the pilot lights the main burner. When the heat kicks off, the main burner shuts off, the pilot stays on. With all that, my highest heating bill in 8 years was $30, and that was in February during a major snow season. It was bad. That was my highest heating bill. Remember, $5 of that is what the gas company charges to service the lines and read the meters. Long story short, I'm quite comfortable with what I'm paying in fuel, but what I really need is reliability. Over 30 years, the furnace has become something of a I'm going to call it a disaster waiting to happen. I've already unseized my motor, so the fan runs great. That's actually been the least of my worries. But what's happening is everything in the furnace is now getting to be quite old, and heat exchangers tend to crack after so many years, and they start leaking. Switches and relays tend to fail over time, and this has quite a few of them, and they're designed for heat safety and limit features. So if it gets too hot, it shuts the unit down. If it gets too cold, it shuts the pilot off. Alright, so let's talk a little bit about that. Rather than give up hope early in the game, I decided to keep this sucker running as long as I possibly could, as long as it was economical. Which means that I was willing to do some repairs as necessary. Looks like it's still lit. The biggest problem I'm having right now is keeping the pilot lit, and I already know what's wrong with it. But I want to talk about how I came to that conclusion. So let's open up the pilot door. Well, this is the pilot lighting and inspection door, and it should be gasketed. If it's not, you have a problem. Let me talk about that first. When I first moved here, the pilot would never stay lit. As soon as the furnace kicked on, the pilot went out. And I'm like, what the hell? Turns out, it's a counterflow unit. So the air coming down, it gets sucked in from the top and blows down. It was blowing between the door and the combustion chamber and blowing the pilot out. Well, that's an easy fix. I bought some gasket material and solved that problem right quick. So the way this pilot works is that once it's lit, now of course when you manually light the pilot, you have to hold this button down, which opens the gas valve manually. It bypasses all the safety piping and everything. And then you light the pilot with either a match or with a lighter, and hold the button down for about maybe a minute or so. The heat then heats up the probe on the thermocouple. And here's the old thermocouple. So here's what the probe looks like. When the flame is applied to the thermocouple, it generates a very low electric current in the millivolt range that travels. See, this pipe, or this tubing, is really just a conductor. The outer copper tubing is the ground, and inside that is a pin. It looks kind of like a coaxial cable inside. And there's a positive and a negative. Now, that other end goes into this gas valve. When the electricity is being created by the probe, it opens the valve, which keeps the pilot fuel flow going. So you can release the button and the pilot stays lit. Well, when the pilot gets blown out, or if there's an adjustment issue and it's not providing enough heat to the thermocouple, it shuts off the gas valve to prevent gas from filling up in this chamber, which could create an explosion hazard. It's a very ingenious design, but things can go wrong. One of the things that I've read online is one of the more common issues is that the thermocouple fails. It is a man-made device and it can fail at any time. So the first thing I did when I had pilot issues, after I eliminated the door issue, I ran out and I ordered one of these. Luckily, I still have the original owner's manual, which I have right here. And I was able to look up on the parts list which pilot, or which thermocouple I needed. It turned out to be part number P028500. So I ordered one. It came 2 or 3 days later. Fast shipping, baby. And I put it in. I did a nice clean install. No kinks, no sharp bends. It's a nice, better looking install than this one. This thing was it was a rat's nest. It was all bent and twisted and it was a disaster. So I put this sucker in, lit the pilot, and it still wouldn't stay lit. So then I kind of opened up my mind a little bit. And I looked in there with a flashlight, and there's all this debris built up on the pilot orifice. It was clogged, clearly. So I did what I could to clean it out. I mean, I can't take the unit apart. More on that later. I got it going again, and then I thought for a minute. I'm like, well, all right, if I can't clean the orifice properly, but I have a flame, what if I make the most out of that flame? So I took the flame diffuser, which is a little piece of metal that was kind of bent like this, but now it's bent more like this through my own doing. And what that does is it forces the flame into the thermocouple. As you see, it does touch the thermocouple. Perfect. It stayed lit for a little while, about a day or two. Then it went out randomly. Shit. So, back to the drawing board. I bent it even more. It's been running fine ever since. But here's the issue. The pilot orifice is clogged. We never did solve that problem. What I did do is, I don't have an air compressor here, so I disconnected the pilot line from the gas valve, and I blew into it as hard as I could and reconnected it. It actually helped, believe it or not. But what really has to happen here is the burner pan has to be taken out. The entire burner assembly, the pilot assembly, all has to be taken apart and cleaned. I have access to an ultrasonic cleaner, and I think I will actually end up doing that, or if I were to go that route. But then I thought of it again. I think a lot. Not very well, but sometimes I think in my own interest. Now, I'm generally one who, I like fixing things. I love repairing things. It's what keeps me alive. If it wasn't for repairing things, I'd probably be shooting up, crack or something, or whatever the drug dealers do these days, or drug users do these days. I'd be over at Cumberland Farms loitering and shooting up heroin or something. If it wasn't for fixing things, I wouldn't be who I am today. Let's put it that way. But when it comes to the appliances that I depend on a daily basis to live my life, while I can fix other people's things for them, I don't like to mess around. When my car starts giving me trouble, I'd rather replace the car than spend tons of money every couple of months repairing it. That's the kind of guy I am. But believe me, I love fixing things, just not my own things. I want my things to work so that I can support the others that pay me to fix their things. The exception being my motor scooter, which is sitting out there freezing. I love that thing, and I'll keep it alive as long as I can. But when it comes to stuff that I need to live, like my furnace and my stove and my fridge, I don't like to mess around. So I've looked at options for replacing the unit because, after all, yes, it has one clogged pilot orifice. But to get to that pilot orifice, I have to disassemble the whole freaking unit. And that's going to mean buying parts. That's going to mean buying a gasket kit, which I may or may not be able to get. That may involve having to replace parts on the gas valve once I get that off, to get the burner off. I mean, it can snowball into tons of parts and money and repairs and downtime, which is something I don't want to deal with right now. So I've decided that for this winter, I'm going to keep it running as long as I can. It's just a matter of relighting it every couple of days if it goes out. It may never go out again. It may be fine for the rest of the season. It could be fine for the next 5 seasons, but that's not a risk I'm willing to take. Everything else in this furnace is original. All the thermo switches, motors, like the fan motor, the gas valve, it's all original. All the electrics, everything is just original to the unit, and it's not really something I want to mess with. So what I did is I looked at some options. I looked at the Rinnai units that my neighbors are putting in. And what I learned is that they don't really offer a solution for a wall thermostat. The Rinnai units have a built-in thermostat with a built-in thermal probe. And what happens is the air coming in tells it how cold the room is. But when you have a 2-story condo, that depends on heat traveling through the unit to keep it warm, and by that I mean it depends on a wall thermostat over there by the banister. It can get pretty hard to heat with a unit like that, and expensive. It'll keep cycling on and off and on and off, which is something I don't want to do. And not only that, but the Rinnai units are infinitely more complicated. They're more compact. They're harder to service. They have a lot of electronics to keep them going. The gas valve and the pilot, actually I don't think they have a pilot. They have an electronic ignition system that's all electronically controlled. This thing can run forever. I mean, they actually, Williams makes a unit that could run even without electricity. But anyway, point being, I am very partial to the simplicity, reliability, and low cost of operation that the Williams furnace gives me. And no, this is not, I'm not being paid to do this. I'm not being paid to promote this company, but I'm just speaking from what I believe. So I went over to the Williams website and I pulled up the current catalog for direct vent furnaces, and I found to my surprise that they still make the exact same unit. And it gets even better. The dimensions are the same. The dimensions, the efficiency rating, and everything is all the same. So what I've elected to do is this spring or in the summer I'm going to order a brand new furnace. And it's going to cost me, hold your hats, $995. That's it. So for $1,000 I can get another furnace that is just as simple and reliable as my original one, and I won't have to worry about it again. Because let's face it, I'm not going to be living here for another 30 years. So my intention is to either sell or rent it once the mortgage is paid off, and hell, even before that if I can. But yeah, so for $1,000 I can replace the whole furnace with a brand new one that is a direct replacement. I don't have to cut any holes. I don't have to put up any trim board. I don't have to paint. I don't have to do anything. Just take the old one out, put the new one in, and the job is done. With the Rinnai units, people are having to cut holes in the walls. They're having to block off the wall up there where the exhaust is, and I just don't want to do that. I don't want to do that. It's too complicated. It's too much work. It's too expensive. And I'm exchanging one unit for one that's going to have a lengthy list of problems after the 5 to 10 year mark. Not something I really want to get into. So let's see if this thing can fire up under its own steam here. And I get to keep my beloved wall thermostat. Goes. And it's lighting itself. That's good. So it's working. My little fix is working. The new thermocouple may be helping, may not be, but what really helped the most is that the flame diffuser has been readjusted to kind of better envelop the thermocouple. Oh yes, one other reason for replacing a furnace of this age, I'm referring specifically to the heat exchanger and all of the seals and gaskets and everything that keeps the combustion gases from getting into the home. One thing I realized while working on the unit is that there is actually leakage in the burner combustion chamber. It's not sealed like it's supposed to be. And I felt around back, and there's no gasketing at all. So, while I have a carbon monoxide detector, but it hasn't gone off through sheer luck. But point being, the furnace has been serviced improperly at some point, or it's just plain aged and getting old and decrepit. That there's a possibility in a very, very short period of time that I may have a bit of a carbon monoxide issue. Let's take the top cover off. I'll show you what that looks like. This is actually the second video I've made on this unit. The last video I made was, I believe, after I fixed the, I think I had done something to the pilot. But here's the top of the unit. And this is the top of the heat exchanger. And this little cover here can be removed for cleaning purposes, I believe. But yeah, it's a relatively simple unit, easy to maintain. But again, after it's been running for 30 years, it's time to consider a new one. Up here, if you look through the fan blades, is the transformer that runs the thermostat wiring or circuitry, and the main burner switch, or valve. But yeah, not much has changed from this unit to the new ones, other than a few components that make it hard to get parts for the old ones. They changed it just enough to make it hard to service the older ones. And it looks like one of the blade... Oh shit, I just noticed that. One of the weights on the fan blade flew off. That's not good. I wonder where it went. Oh man. Yeah, this thing spins nice and freely. That's good. That means the bearings are still free. When I moved here, they were frozen solid. So I had to take the whole thing apart. That was my first project, my first winter here. I had to fix that in the winter, of course, naturally. Yeah. But yeah, it's time for a new one, and I'm willing to spend $1,000 for what I consider to be $1 million worth of peace of mind. So. Closed up. I've picked out the model. I'm not going to go for the electronic ignition model because I don't want any more complexity. I'm willing to just shut the gas off in the summer to keep the pilot off, and then in the winter I kick it back on again. Problem solved. No need for electronic ignition. But all right, well, I'm going to call this a day.